Today we're going to be looking at lesson 5.7, systems of linear inequalities. Now let's review systems for just a second. We've done system of equations, and how many equations were in our systems? 2, okay? So today we're going to be looking at systems of linear inequalities. So we're still going to have 2, but they are going to be inequalities instead of equations. Now, in example number 1, we're going to start simple. It says, tell whether the ordered pair is the solution of the system of linear equations. Now, they've given us a point. So what are we supposed to do with the point that they have given us? Plug it in. We're going to bring down the first inequality. So y is less than 5. And then right beside it, we're going to bring down y is greater than x minus 4. All right, that's the first thing we're going to do is bring down both inequalities. Now, what is the y value in the given ordered pair that we're supposed to plug in here? 5. So we plug in 5, and we bring down is less than 5. Now, is that a true statement? Is 5 less than 5? No, so we're going to cross that little symbol out. And do we need to go any further? Is there any reason for us to plug the ordered pair into the second inequality? Yes or no? No, because the point has to make how many of the inequalities true? Both of them. So since it didn't make the very first one true, there's no reason to go further, and we're writing down not a solution. Now remember, we're not writing down yes and no. We're writing down solution or not a solution. And this is not a solution. So that ordered pair would not fall into the shading of this graph. Now let's look at letter B. So we bring down the inequalities first. We have y is greater than or equal to 3x plus 1. And then y is greater than x minus 1. All right, what is the y coordinate that we're plugging in this time? 4. And that's greater than or equal to 3 in parentheses because we're multiplying. What are we plugging in place of x? 1 and then plus 1. Do we multiply first or do we add? We multiply. So 3 times 1 is 3 plus 1. What is 3 plus 1? Okay, so 4 is greater than or equal to 4. Is that a true statement? Yes. All right, then we move on to the second inequality. Again, what are we plugging in place of y? 4 is greater than, what are we plugging in place of x? 1 minus 1, and 4 is greater than 0. Is that a true statement? Yes. Now again, you could circle these if you want. You don't need to box them because they're not the final answer, but we do need them. Okay, here's the other thing you need to make sure of. Don't skip this step right here. Don't assume Miss Johnson knows that you know 1 minus 1 is 0. Okay, I don't. I need to see why you chose solution or not a solution. So if both statements end up being true, is the ordered pair a solution? Yes, so final answer that you would write and box in would be solution. Now, example 2. We need to be able to graph inequalities. So before we can graph these inequalities, we need to talk through how to do it, all right? Step number 1, plug into Desmos, okay? Piece of cake, we've been plugging things into Desmos for a while now. I will tell you this, make sure before you go to step number 2 and you start to copy the graph onto your graph paper that you are zoomed in to where you're counting by ones, all right? That's how we're going to do this. We're going to zoom in, we're going to count by ones. It's going to help us to keep our graphs from getting too large and going off of the graph paper, all right? But look at step number 2. There's some things you got to be careful of with inequalities that you didn't necessarily have to think about with equations. First of all, pay attention to the solid or the dotted line. You would think, since Desmos is doing most of the work for you, that drawing the correct line would not be a problem. But that's not happening, all right? I've got people looking at a dotted line on Desmos, but by the time they get to their paper, they're just used to drawing a solid line, and they're drawing a solid line. All right? You say, well, Miss Johnson, how can I be really, really sure? Well, you tell me, when should my line be solid versus when should my line be dotted? What am I looking for if my line is solid? Kayla?
Equal to.
Okay, the inequality symbol greater than or equal to or less than or equal to. So you've got your inequality symbol, but it's got the line. It's the or equal to. All right? So when is my line supposed to be dotted? When the symbol is what? Just greater than or just less than. All right? So you should be able to check. Look at your original problem. My problems were both or equal to problems, so my lines should both be solid. They were both just greater than or equal to, so they should be dotted. All right, so that's just to help you check and make sure that your work is right. Okay, so that's the first thing you got to pay attention to. The second thing when you're pulling stuff off of the Desmos and onto your graph paper is this, and this is key. The shading will be where the two sets of shading intersect. So I want you to highlight the word intersect, and then I want you to think about it. Each line has its own shading. You saw that in the flipped classroom last Thursday. When you graph a line, an inequality on a graph, there is shading, either above the line or below the line. Okay? But what happens when you're graphing two lines on the same graph? The shading is going to overlap. That is where your solution lies. So you're not just going to go crazy and shade everything. You have to find where the two sets of shading overlap, and that's the only thing that you're going to shade on your graph. All right? So highlight the word intersect, and we'll talk through this as we go. All right, now, example number 2. Graph the system of linear inequalities. So go ahead, pull your phones out, open up Desmos, lay your phones flat on your desk, and we are going to talk through these. I'm going to put Desmos up on the screen for those of you that do not have a phone with you, because I don't have any iPads right now. So I will get Desmos up onto the screen for you. What is the first inequality that we are plugging in?
Y is greater than equal to
All right.
X plus 4.
Good. Now, remember the keyboard button right here will give you your greater than or equal to and your less than or equal to button. So this is y is greater than or equal to negative x plus 4. All right, and what is the second inequality that you plug in?
X plus y is less than or equal to 0.
Good. X plus y is less than or equal to 0. Now, you can see very clearly that we have what kind of lines? Parallel. All right. So what is our solution going to be? What's our, typically when we graph and we have parallel lines, what's our answer been? No solution. All right. But let's graph the lines first, and then we'll talk about if that is actually the case when you're dealing with inequalities. All right. First of all, let's deal with the red line. All right. What is a very obvious point? And you can see I need to zoom in, so I'm counting by ones. What is an obvious point on the red line?
0, 4.
All right. So if I use 0, 4, if I choose to use that intercept, then I'm going to go right above that point and right below that point. Remember, we're trying not to spread our points out too much, because that's when we tend to mess up. All right. So if I move up from 0, 4, what is the next exact point that I hit?
Negative 1, 5.
All right. So we type in negative 1, 5. We label it. All right. And then if we go down from that 0, 4, what's the next exact point that we hit?
1, 3.
1, comma 3. Okay. So here are the 3 points. Now remember, we need points that are labeled, and we need what on both ends of the line? We need arrows, okay? So make sure that once you draw the line, and listen, draw that line from one side of the graph to the other. Because if you don't, you tend sometimes to not shade enough. So we want to make sure that our lines go, whatever the size of your graph, make it go from one side of the graph to the other. All right, now let's talk about the blue line. What are some exact points on the blue line?
0, 0.
Good. I like 0, 0. It's straight and to the point. All right, so go up from 0, 0. What's the next exact point that you see?
Negative 1, 1.
Negative 1, 1. And then down from 0, 0, what do you see?
1, negative 1.
All right, we've got 1, negative 1. Okay. There we go. So again, make sure you plot your 3 points, make sure you label them, and make sure the arrows are on the end. Now, let's talk about the shading. Remember, the shading that we are supposed to put on our graph paper is supposed to be the shading, or where the shading of the two graphs overlap. Is there any overlapping of shading in this particular problem? No. So, should you have any shading on your paper? No. Okay? You do not put the shading above the red line, and you do not put the shading below the blue line, because there's no overlap. Okay? The solution is the overlap of shading. So if there is no overlap, then there should be no shading on your graph. So, is the answer still no solution? Yes. There's nowhere where the shading overlaps. So there's no point that is going to fall into both, into the shading of both lines. So this is still parallel lines give you an answer of no solution. So go ahead above the graph, right next to the original problem, write and box in no solution. So right next to the original problem, we can write no solution. Now, go ahead into Desmos and plug in your second set of inequalities. All right, the first inequality you have is negative 2x plus y is less than 4. And then you have 2x plus y is greater than 4. Now, remember with Desmos, you can change the color of your lines. And when my lines look this close in color, I'm not a huge fan. So I'm going to make, if I hit the setting button, it allows me to go change the color. So I'm actually going to change to orange. And I'm going to change this one. I don't like red, so how about blue? All right, that way I can distinguish a little bit better, especially when it comes to the shading part of this. All right, let's start with the blue line. Now, here we are. The two lines are actually intersecting, and even though that's not going to be our final answer, that is still a great point for us to actually plot because it takes care of 1 point on both lines. So what is the point of intersection for these two lines? All right, so we're going to do 0, 4. We're going to have it labeled. All right, let's do the blue line. Elijah, if I move up from the point of intersection on the blue line, I'm zoomed in, I'm counting by ones. So what is the next exact point that I come to? All right, so we're going to type in negative 1, 6. We're going to make sure it is a point, and it is. All right, KK, down from the 0, 4 on the blue line, what's the next exact point I get to? Say that again. No, you went too far. I'm trying to stay close to that point of intersection. So if I follow that blue line down, what's the next exact point that I hit? 1, 2 would be the next exact point that I reach. All right, good. Let's go back and let's do the orange line. Kyle, if I go back to that point of intersection, let's go up the orange line. What's the next exact point that I hit?
1, 6.
All right, so 1, 6. And then Xavier, if I go down from the point of intersection on the orange line, what's the next exact point that I hit?
Negative 1, 2.
All right, negative 1, 2. Perfect. Now, go ahead, plot your points, make sure they are labeled, and what should go on either end of your graph? Your arrows, okay? Again, now here it's very important. Draw those lines from one end of your graph to the other. All right, so use that ruler. Also, what kind of lines should you be drawing on your paper? Dotted. All right, I know you're so used to just doing solid lines, so be careful. All right, these lines are dotted because if you go back to the original problem, both of the inequality symbols were, you had a just less than and you had a just greater than. All right, I circled the wrong thing. So just less than and just greater than. So your lines should be dotted. All right. Now let's talk about the shading. Let's talk about the shading. And remember, you can play around with these. If I click on the orange circle, it'll actually take the orange graph off. So for just a minute, I can look. Do you see where the shading is on the blue line? All right. So let's put the orange back and let's take the blue off. Do you see where the shading is on the orange? The question is, where do the two shadings overlap? This section, or this section right here? This section right here. So you cannot shade here on your paper or it will be wrong. You can't shade here. The place where the shadings overlap is right here. It's this area right here. So this is where the only shading should be done on your paper. Now, that brings us to example 3. They want us to write a system of linear inequalities that are represented by the graph. So they are giving us the graph this time, and they are asking us to write the system of inequalities. Now, you can see right in your notes, I've given you the 3 steps. These are steps that you have seen before for other types of graphs. So highlight the steps. It says find M and B. Everybody tell me, what does M stand for or represent? Slope. And what does B stand for or represent? The y-intercept. So we got to find the slope and the y-intercept. We're then going to plug it into our most favorite formula ever, the slope-intercept form of a line, which is y equals MX+B. But we can't leave it like that because we can't have an equal sign if it's an inequality. So we have to finally decide on the inequality symbol. And that's where we're going to look at the shading and the lines to decide if it's greater than, less than, greater than or equal to, or less than or equal to. So let's look at letter A. We'll work it together. And we are going to start with, I'm going to call this the first line. All right, we're going to start with this line. So can anyone tell me which is easier to find, the M or the B? The B is the easiest thing to find first. So where does our line cross the y-axis? 0? 0's here. 0, 2. It crosses at 2. Okay? Now, what is the quickest way after I write down that B equals 2? I now need to find the slope. What is the quickest way to find the slope when I'm looking at a graph? Rise over run. So I've got to go find one more point. And again, there's a point here. There's a point down here. It does not really matter. I am going to use the point closest to the y-intercept. Now, I've got to connect those points to find my rise over my run. Michaela, if we started at the top point, would you go down first or right first? How would you get from one point to the other?
Down.
So you go down and then you go right. Now, how many spaces down did you move?
1.
So is that positive or negative?
It's negative.
Negative. You went down and then you went to the right how many spaces?
1.
Positive or negative?
1. Positive.
Going to the right is a positive direction. So Michaela, what does that make your slope? If my slope is rise over run, what's that make my slope?
Negative 1.
-1 over 1 or -1. All right? Now, Avery, we're supposed to take the M and the B and plug it into y equals MX+B. So what does that look like if I do that?
Y equals -1 plus 2.
Just -1 plus 2?
Oh,
-1x plus 2. Awesome. Now, I know I can't leave it like that because this is an inequality. So I've got to get rid of the equal sign. So I'm going to go ahead and bring it down. I'm going to leave myself a space. And I'm going to bring down the -1x plus 2. Now, be careful. Look at the shading. The shading for this line, is it above the line or is it below the line? It's below it. So is that greater than or less than?
Less than.
That is less than. So we put down our less than symbol. Then we ask ourselves one more question. Just less than or less than or equal to?
Less than.
Why just less than?
Just dotted.
The line is dotted. Perfect. So you're done with your first inequality. Now, be very careful with the second line because what kind of line is the second line? It's vertical, okay? So here we are again faced with hoy or vux. So if I'm you, I'm writing myself a note in this vicinity somewhere around this problem, hoy question mark, vux question mark. Because I don't want to waste my time trying to find M and B if I don't have to. Horizontal lines and vertical lines either have a slope of 0 or a slope that is undefined. So why am I going to waste my time finding the M and the B if I don't have to? All right? So we said this one's vertical. So vertical lines, is that an X in the equation or inequality, or is that a Y in the equation or inequality? If it's vux, remember vertical lines have an undefined slope and x equals something, okay? So x is the variable that should be in our inequality. Now, the number, where do we get the number? If it's x, we look at where the line crosses the x-axis. So where does the line cross the x-axis?
-1.
Be careful, we're looking at the x-axis. Right here, right? Right here at 3 is where it crosses the x-axis. So 3 is the number in our inequality. Now, the shading. Is the shading to the left of the line or to the right of the line? So is that less than or is that greater than? Less than. As I move to the left on the x-axis, my numbers get smaller. All right, last question. Just less than or less than or equal to? Why just less than? The line is dotted. All right, so then we draw our brace to the best of our ability, and this is the answer we box in. There is the system of inequalities for this graph. Let's start with the first line. Vertical or horizontal? This one's vertical. So is there any reason for us to take the time to find the M and the B if we have a vertical line? No. What variable is going to be in our inequality if this is vertical? All right, X. Where does the line cross the X-axis? -1. And Morgan, is our shading to the right or the left of that line?
The right.
So that makes our symbol
Greater than.
greater than. Now, just greater than or equal to?
Greater than or equal.
Why or equal to this time?
The line is solid.
The line is solid. All right, very good. So that takes care of the first line. Now, let's look at the second line, which is what kind of a line? Horizontal. So our variable for our inequality is going to be a what this time? Y. Okay, so there's no need to find the M and the B. We're going straight to Y. Where does our line cross the Y-axis?
3.
So 3 is the number in our inequality. And then the shading, Kiana, above or below the line?
Below.
Which makes it which symbol?
Less
Less than. Just less than or less than or equal to? Why just less than? Because the line is dotted, it's just less than. So we put our bracket or our brace, and that is the system of inequalities for that graph. And that is lesson 5.7.